current productivity.
Thank you for your interest in Nakamura-Tome. Complete mill turn software that you are about to see will make your investment in multitasking successful and very profitable. The software is not a CAM system. It is simulation software using actual G-Code programming to analyze, optimize, and verify your process with full posting capability. The success of the software is the full 3D model of your machine directly from Nakamura-Tome, the builder. So enjoy the next few minutes. This is your real, true path to multitasking success. Thank you.
Before an airplane takes off and a pilot lands at a given location, he sits in a cockpit that is the exact model and type of the airplane that he is flying. He simulates landing at different airports, and this makes aviation travel one of the most safest forms of travel in the world. What if you had the exact model of your Nakamura-Tome? What if you had the ability to simulate exactly what's going on at the machine? This is what we're offering you with the Complete Turn Mill package that comes with every multitasking Nakamura. Let's take a walk through our simulator. I'm going to go ahead and start cutting this part or playing the simulation of this part. And I think what we'll do is we'll just go ahead and open up the door here and zoom in and take a look at this running, cutting a sample. As you can see, I have true simulation of the part running at the actual speeds that the part is cutting. This simulation is so perfect that if I was to actually zoom in on the control and you to look at the control, you'll see that the actual G-code is running on the control as the part is being made. This is true verification of the G-code. This is not the same as a CAM system which verifies a toolpath but never truly, even when the code is posted out in G-code, gives you the true simulation of the part being cut on the machine. This is true simulation, actual time, even accel decel rates of the machine are in this software. Complete Turn Mill bridges the gap between all CAM systems and your Nakamura-Tome machine tool. It provides everything you need to analyze, modify, optimize, and simulate multi-axis toolpaths in an integrated 3D environment. We are actually in a simulator, so therefore we can slow things down, speed things up for optimization. We can verify whether we are in an over-travel condition, whether we have a collision. In this particular video, what you'll see is that this NTMX B-axis machine has a tool setter. It's an automatic tool setter, and we can also check the G-code and verify that the tools are being set correctly. I like this little video here. Look how close the tools are to the work holding. Look how close the tools are inside. Indexing that B-axis tool holder. Those are actual solid models of the collet change, collet holders and tooling. Now on this one, take a look at how close the corner of that B-axis comes to the collet holder. This is actual positioning and true verification. This would be very nerve-wracking even at the control, single blocking and stepping this through. This was an actual part that we cut at IMTS. In this particular slide, what we're going to see is a simple master cam turning project. We're turning, facing, and finish turning. What I like to show here is even if you have a simple seat of master cam for a standard lathe, maybe you don't have the multi-lathe package, you can still use that for your upper turret, main spindle, and you can move and drag those tool paths around anywhere in the machine, as you'll see in a later slide. So here we have the Mastercam project actually being simulated in Camplete. We'll go ahead and watch it again as it cuts the Mastercam toolpath. In this particular case, we've added a different toolpath because I'm going to demonstrate a collision. When you have a collision, this alarm page will come up, and if you move forward, you'll see that a collision turns red. So from an optimization standpoint, you can adjust the software model to match your machine. It simplifies multitasking. You don't have to stand in front of the machine and change things around. You can do it all offline while you're still making parts. And it is so easy to move and reorder toolpaths. Watch this next slide and see how easy this is. I'm going to go ahead and show you how easy it is to operate this software. I'm going to import a couple of programs for my upper and lower turret, and I'm going to go ahead and delete the program for the toolpath on that lower turret. I'll go ahead and select a tool, put it in tool position number 1. Here's a typical lathe holder. Camplete will show you the tools that fit that lathe holder. It doesn't show you your whole library. It shows you the tools that fit, which makes it easy for selection. I've selected a roughing tool, and I'm going to adjust my stick out length. I can do it visually, or I can go ahead and type in a dimension. I'm in metric, but I'm still going to type in an IN, and it automatically knows I'm in inch. To show you how easy the software is to manipulate, I'm going to go ahead and show you how easy that is to flip from the main to the sub. Now I'll generate this program, and I'll simulate it. This is the actual speed and feed of this toolpath with its rapid motion cutting on your Nakamura machine. Toolpath looks great. For this particular demo, I'm going to go ahead and speed it up 200%. I can change the speed and watch this at any speed for optimization purposes. Looks great. Now I'm going to take that toolpath and drag it to the lower turret. I'm going to copy it. I'm going to go ahead and reverse my X's and my arcs for the subspindle. And I'll go ahead and pick a tool position. And number 1 is open, so I'll go ahead and grab that. Camplete automatically updates the G-code for the other side lower turret. I'll regenerate it and test it. As I play this, again, I'm 200% speed, but you'll notice that with the click of a button, I now have a toolpath on the left and the right, even though I've only generated a toolpath for that left side. Well, that worked so well, I'm going to go ahead and drag the one at the top down. I'm going to copy it, and I think I'll do some pinch turning. Tool position number 1's used, so I'll grab tool position number 3. Camplete updates the G-code automatically for the correct tool. And I'll go ahead and play this after I simulate it. Generate it, that is. And here we go. Bang, I'm pinch turning. Now notice, the rapid moves on the machine are simulated exact, and they're not in sync perfectly. So I'm going to go ahead and put some sync code or weight codes in there so that this will run perfectly. Camplete has one of the best weight code or sync editors out there. I click on the button, and I'm going to go to my G1 moves and go ahead and put in a weight code. It automatically puts the weight code in from the last number that you used and puts them in sequential order. You can also go through and put all your weight codes in order if they're somewhat messed up. Just that quick. I'm inserting weight codes for my G1s to make sure that when those tools begin to cut, they are perfectly in sync. We'll go ahead and regenerate it. Take a look at it again. And now watch these two tools. Even though the rapid retract isn't exact, when they go to start cutting, they are perfectly synced. Works so well, I think I'll go ahead and do it for the right side spindle, sub-spindle as well. Take that tool path, drag it up to the top, copy it, I don't need to reverse these in arcs. Pick another tool position for number 2. Generate it. I've loaded 4 tools on my turrets for the main, for the sub, all from one tool path, generated them. I am now pinch turning to the left and pinch turning to the right. This is easy software. We train in one day. Looks great. Even from the milling standpoint, if you do milling on the top, you can pull it down, copy it, and you will be now pinch milling as shown in this particular video. We have the actual models for all of the holders for Nakamura. We have all of the collet holders and chucks and live tooling that you would use on your Nakamura lathe. These are all models from the people who build tooling, and everything is associative. If you pick a chuck, Camplete will only show you the jaws that fit in that chuck, so you don't have to search down through this long library. If you pick a live tool holder, you can build whatever size end mill you like, or you can pick one of the standards. Same thing with collets and sleeves. Watch how simple this is for verification. I'm just going to pick my main chuck, and I'm going to go ahead and select something. I'll just grab this Kitagawa chuck. Instantly it's on there, and there's a button that shows up now that only allows me to see the jaws that fit that chuck. I'll go ahead and pick it. Well, I changed my mind. I could have the job all done. I'm just going to go ahead and reset, and I'm going to go ahead and put a collet holder on. I'll grab this Royal collet holder, and again, Camplete will only show me the collets that fit that Royal collet holder. I'll grab a 2-inch. And I'm ready to go. Now I'll go to the tab for the part. I'll select my part for the main, just a simple IGES file or STL file, and I'll go ahead and adjust the stick out length for what I want from the collet, and I'm ready to go. Anytime you have tool paths, if you move your part in the work holding, all your tool paths will move with it because everything is associative. It's so simple. If I have a tool that's hitting the sheet metal, I can very quickly change that regenerate and move it so that everything is good, and instantly I've got updated code and updated tool lengths. Watch how easy it is to grab a tool. For tool number 1 here, I'm just going to show you some tool holders. There's a half station indexer. Here's a standard tool holder. I'll go ahead and grab that. As soon as I do, it will show me the tools that fit that tool holder. 55, 80 degree. Grab the tool that you want and adjust its stick out length. You want to change the tool? Go ahead and grab one that's for the other side. Change your stick out length accordingly, and you're ready to go. In this particular one, I'm going to grab a different holder because I want to show you that different holders have different properties. This time it pulls up 2 positions. One is for the tool I want to put in this case, just an indexable drill, and I'm done. Oh, maybe I want to change the drill size. Fine, just go ahead and pick a different drill size. Great, it's done. Well, what if I wanted to load a boring bar in here? That's fine. I'll just grab a boring bar here. Well, that's not exactly what a boring bar looks like. There's usually a sleeve because it's a smaller diameter, so I will grab the sleeve. Again, it only shows me the sleeves that work. And just that quickly, and I have a sleeve, which is important to show because I could collide into that sleeve. I adjust my boring bar length, and I'm done. It is true verification. Here you have the actual solid model of the machine to the left and the machine to the right. I mean, these are factory models. We have them for all Nakamura multitasking machines. This is just a sample of a number of tool paths put together. Here I'm pinch turning an OD, and then I'm facing and finishing and rough turning the other side. Each one of these tool paths was generated independently, and then I went ahead and put them in. I'm milling the lobes on the left while I'm finishing up turning on the right. I have the ability to take all these tool paths, move them and reorder them to balance my cutting on the left and the right. In this particular slide, what you're going to see is the software running and the actual part being cut. The timing is not perfect, but it is very, very close. Normally, a complete project is within a couple of % of the actual cycle time. Unlike typical CAM systems where it can give you a feed rate time, the rapids are never correct because they don't take into account accel and decel rates and tur indexing positions. You could literally program a job, get an estimated cycle time, and quote your work to a customer. As you can see, the software to the actual cutting of the machine is very, very close. In G-Code editing, you can literally watch your G-Code as if it was on the control, go right down the program, you can single block it through, or you can see exactly what's going on, and you can modify simply. In this particular part, same one we had before, I'm just going to go ahead and pull up the editor, and I'm going to start the program and allow you to watch. As you can see, it highlights the actual G-code that you're on as the program runs. The left one is for the main upper, and the right one is for the lower sub. I can take the slider and slide to any position in the program, as I was doing right there. I can zoom in, go slow, backwards, forwards, all the time showing the exact code. If you should have an alarm, you'll be able to find it quickly. Now I'm going to go ahead and edit this real quick, and just to show how I edit it, I'll click the edit button, and I'm just going to change the tool from tool number 6 to tool number 1. I've now edited the G-code, and I'll go ahead and move the tool. Watch how easy this is. I'm going to grab the tool from tool number 6, and I'm just going to drag it to tool number 1, and it's ready to go. I regenerate it, and I'm ready to check it again. Nothing could be simpler, more powerful. It shows the direction of rotation of all tools. That's what those green arrows are. For analysis, again, I've got true cutting speeds. I can monitor all aspects of machine motion, all right, and motion deviation. So I can get down to nanoseconds. And for those of you that are doing high volume parts where fractions of a second make a difference, because if I can save 10 seconds on a cycle time and I multiply that over thousands and thousands of parts, that's a lot of money. For those of you that are job shop people, having the ability to test and evaluate and set up before you ever go to the machine is an amazing thing. Campley gives you some really great setup sheets. As you can see here, it takes a picture of whatever's on the screen when you tell it to print out your setup sheets. And you can set these up pretty much any way you want. You can set them up to show you the program, the weight codes. You can make them as long or as limited as you like. I've kind of set these sheets up just the way that most customers would. That gives us an overall summary of the job. This happens to be a 3-turret twin spindle machine, 2 upper, 2 lower. They all have Y-axes. And, we did a demo job on it. The data that it gives you on all the tools is very good. It gives you the tool number, the tool holder that's being used, the tool itself, even the insert if you need it, what spindle it's facing towards, and the tool length offset. And it does that for every individual tool. It also gives you the offsets for the tools. Now, this is obviously coming from a CAM system, and it's not going to be perfect. A guy throws a ruler up there, and he has an 1.5 inch extension. He throws it in there, he puts it in, he clamps it down. He's going to be off by a certain amount. However, when you go to touch off your tools, you can legitimately look at your offsets and compare them with the sheet. And they're not going to be perfect, but obviously, if you've got a dimension that's minus 8 inches and it winds up being minus 12 inches when you touch your tools off, something's wrong. And that's a good indicator to let you know that, hey, something's wrong somewhere. Again, a great list of all the tools. Then you come down and it will give you the work holding, the work piece, the extension distance of that work piece, and you've got everything you need so that tools can be set up offline, ready to go, and when you're ready to change that job out, your changeover time and your setup time is going to be greatly reduced. The program has already been proved out, so you don't have to single block very much, and you're ready to try and start making good parts. Thanks for taking the time to watch this presentation. We at Methods Machine Tools not only want to offer you some of the best machine tools in the world, but we want to offer you the tools to succeed.
over 55 years, Methods Machine Tools, Inc. has been North America's foremost supplier of leading-edge precision machine tools and solutions, providing superior products, engineering and automation, parts and service. This unrivaled combination of machine technology, application expertise, and service enables manufacturers to consistently obtain highly productive, profitable operations and quality parts. Our long-term partnerships include Nakamura-Tome for turning centers, Fanuc Robo-Drill for compact machining centers and wire EDM machines, Kiwa for expandable horizontal machining centers, Yazda for jig borers, jig mills, precision centers, and micro centers, and Feeler for machining centers, turning centers, bridge mills, and boring mills. Fanuc wire EDMs provide superior finishes and are equipped with the best auto threader on the market. We provide vision gauge digital optical comparators. We have also partnered with dozens of top suppliers for automation, tooling and fixtures, ancillary products, and quality control. Methods factory-trained service specialists are here to support you with any electrical, mechanical, preventative maintenance, spindle repair, or installation needs. Our application engineering team is dedicated to solving customers' challenges and integrating modifications. State-of-the-art robotics and customized automation give manufacturers unmanned production, fast tool changing, and reduced cycle times. Our training experts offer a full range of training classes at each regional facility. Our extensive part selection has 95% of orders in stock and ready to ship the same day. Methods Finance Group offers customized solutions and works with each customer to provide a tailored financial plan. Our headquarters resides just outside of Boston, Massachusetts, with regional offices providing sales, engineering, training, and service support across the United States and distributors throughout North America. Methods brings you a support system like no other manufacturing solutions provider. We support you from selection to service. You get our team with every machine. Methods, your partner in productivity.